Today we are going to go over how I designed my fursuit head. So let's go to the main sort of CAD drawing and start from the start here. So if we go all the way up in the feature tree, you can see that the first thing here is a 3D scan of my head. So this is me, and I designed the entire head around this. So then next, I used the Power Surfacing for SolidWorks plugin which adds sub-D modeling to SolidWorks to design the head itself. So I'll just quickly show you what that modeling environment looks like. So you can see this is a very Blender-like environment where we can like push and pull like everything freely, and you have like complete control over the design, but it's not parametric. So we'll discard changes here, and now you can see that we have this thin surface here. So now if we thicken everything, you can see now we have the head and it's thickened. If we take a cross section, you can see it's about that thick. The next thing we do is we split this part into multiple pieces. So you can see that we have this very nice surface here, which cuts the moving jaw out. So we have the jaw and we have the head. So we'll go back into a section view here. And the next step is this padding. So the padding is what actually interfaces between the fursuit head and my head. So you can see I have this representation of my head on the inside here that is parametric. You can see the foam padding goes in and touches my head, just like that. And this is inspired by a bicycle helmet because I wanted it to have very high amounts of ventilation. The next step here is these jaw hinge features. So you can see that we have a plate at the top and bottom with rounded holes to mount springs inside of to hold the jaw closed. And on the side here, we have a hinge mechanism. So you can see this has a rib here to connect it, and we have a place for a nice screw to go in, and it's not modeled in this part of it, but you can see there's a spot for a lock nut there as well. And then the final step is that we separate this out into areas that we want to lighten and areas we don't want to lighten. Here I'm showing all the areas that we do want to lighten, and here you can see all the areas that we want to preserve. We don't want to lighten any of these areas. So now we'll enter the NTOP. NTOP is another CAD software, and I'll just quickly show you. This is the head that I've loaded into NTOP. You can see we have all of the preserved regions, and we have all the areas that we want to lighten. So first I'll sort of show you how this is working. So we are mapping a bunch of stuff in this spherical cell map here. So one of them is this hexagon unit, or this triangle unit here. Let's see. So you can see this. We've got one of these. We've got like one that's thicker. We've got some cylinders. Got some really big cylinders. We've got small cylinders, and these combine together to form what's called an isogrid, which is a structure that's used a lot in aerospace. So I'll just quickly show you what this ends up doing. So we combine, for example, this inner isogrid with the area that we want to lighten, not that one, this, and the result is this. So you can see now we have an isogrid that goes across this entire surface. But of course the isogrid also has a skin, so we also include a thinner skin on the outside. You can see that's a lot thinner. And when we get this all together, we end up with something that looks like this. And this is what I got printed. And I got this manufactured at PCBWay with their resin printing using UTR 8220. So the next step is how I managed to model all of the fur patterns, and you can see that we have, I've opened here ExactFlat. This is the website for another SolidWorks plugin that I used to flatten all the fur. And if we go into SolidWorks here with ExactFlat, you can see these are all of the parts I designed. So if we go over to view the model, you can see this is with everything that's 3D, with all the colors on it. the flattener program takes this 3D surfaces and then runs a physics simulation to flatten them and optimize it to have the perfect shape. Oh god, I clicked OK, not cancel. Oh no. Oh my god, I have never heard that. Problem with exact flat is that it's very buggy, and if you click things in the unexpected order, it will just crash. So we're not going to save this. Alright, so we're going to try this again. Okay, we're back. So in this modeling environment, after we flattened all of the 3D surfaces into 2D surfaces, then we add these seams around the edge, and we can add alignment notches and all kinds of things to this. We go to the markers window, and we can see that now it gives me the option to nest everything together. I didn't actually opt to buy the nesting plugin because it was $4,000, so I just have to move it around manually by hand. The Lightburn is the software that I use with my laser cutter, and you can see here that, for example, we'll load one of the black pieces, and you can see it has different colored lines for different laser powers that it uses to actually cut this. So the green and the blue lines and the black lines are just sort of etched onto the fabric, and the red lines are what is actually cut. And I'll have some footage in here showing the actual pieces being cut out with the laser.